Happy morning, students. Today we are going to see the silicon tetrachloride group 14 carbon family. The next compound of silicon is silicon tetrachloride. The valence of silicon is 4, so it forms a silicon SiCl4. Now see the preparation. Silicon tetrachloride can be prepared by passing the dry chlorine over the intimate mixture of silica and carbon by heating to 1675 Kelvin in a porcelain tube. Silica means SiO2, carbon, and passing a dry chlorine is Cl2. That gives Si. Yes, silicon is Si. Chlorine, how many chlorine is there? 2 2s are 4. SiCl4. Then carbon, here is O2. Now take the 2 moles of carbon, 2 carbon monoxide. So how to prepare the silicon tetrachloride means take a silica. Silica is SiO2 with carbon and passing a dry chlorine. It gives a silicon tetrachloride and carbon monoxide. The next one is commercial scale. The preparation of silicon with hydrogen. Preparation silicon with hydrogen chloride gas HCl or above 600 Kelvin. How many? Above 600 Kelvin. Now write silicon plus 4 HCl, that is hydrochloric gas. You will need 4 chlorine, so you take a 4 moles of hydrochloric gas, chloride gas. Write here SiCl4. The remaining 4 hydrogen is there. 2H2 gas is evolved. See the physical properties of silicon tetrachloride. It is colorless, fuming liquid. It freezes at -70 Kelvin. In moisture, silicon tetrachloride is hydrolyzed with water to give silica and hydrochloric acid. Now take SiCl4. SiCl4 react with 4 moles of water. 4 moles of water means right. OH, OH, HOH, HOH, HOH. Now remove 4 HCl, 4 HCl. The remaining is SiOH 4 times. This is silicon tetrahydroxide. Now when hydrolyze silicon tetrachloride, hydrolyze with moist ether. This is moist air. This one is moist ether. You will get the linear perchlorosiloxanes are formed. Ether means OX. Okay, now write here SiCl2O. This is ether form. Outside one chlorine is there. Here is outside SiCl3. So it's a polymer. Polymer means there will be a linkage will be there. So linear perchlorosiloxanes are formed, where N is equal to number of SiCl2O is 1 to 6. Okay, with moisture it gives SiOH 4 times. With moist ether you will get Cl, SiCl2O. This is ether form. N times SiCl3. That is linear perchlorosiloxane. Alkalization. The chloride ion in SiCl4 can be substituted by nucleophile. What are the nucleophile? Hydroxide ion, then ether oxide ion, alkyl oxide, aloxide ion. This is hydroxide ion. Hydroxide ion. Here is aloxide ion. Aloxide ion. Using a suitable reagent. For example, it forms a silic ester with alcohol. Take alcohol. This is CH5OH ethanol. Here is SiCl4. How many chlorine is there? 4. Take 4 moles of ethanol. Now we are going to remove the hydrogen here. So 4 HCl. 4 HCl. The remaining is OC2H5 ethoxy. So SiOC2H5 4 times. That is tetra. This one is number of carbon 2. Ethoxysilane. Tetra ethoxysilane. Amylation. Silicon tetrachloride undergo amylation to form a chlorosiloxanes. that is SiCl4 react with ammonium. It gives chlorosiloxane. You take 2 moles of SiCl4. Now write here. Split 1 chlorine outside. Okay. Now ammonium is NH split like this. And here is 1 more moles of silicones. This is SiCl4, SiCl4. Remove HCl. Here also remove HCl. Now it forms SiCl3. That is SiCl. The link between Si to nitrogen, then Si. So write here Cl3 Si. Cl3 Si. Now center is NH. Here is SiCl3. That is chlorosilazine. Uses of silicon tetrachloride. It is used in the production of semiconductive silicones. So it's a semiconductor, so partially conduct the electricity. Semiconductor, add any impurities. Okay. It is used as a starting material in synthesis of silica gel, silica esters, and binder for the ceramic material. What are the uses of silicon tetrachloride? Use the production of semiconducting silicones. It is used as a starting material. We can use the SiCl as a starting material to prepare the silica gel, silica esters. This is a binder for ceramic material. So silicon tetrachloride is finished. Then next we are going to see silicones. What is silicones? Silicones are polysiloxanes or organic organosilicon polymers with general empirical formula R2SiO. R2SiO. R is mentioned alkyl. What is this? Alkyl. So silicones are polysiloxane, the organosilicon for polymers with general empirical formula is R2SiO. The empirical formula is similar to that of ketone. What is the formula of ketone? RCOR. This is the general form. RCOR. So alkyl is 2. R2CO. They are named as a silicones. For ketone means we used to mention as a cones, silicones. That means CH3, COCH3. What is this? Number of carbon is 3. This is ketone group. How will you mention here? Propanone. Propanone. Instead of carbon, you are taking, what is this? Silicon, Si. Instead of carbon, you are going to take Si. So that you are mentioning as a silicones. These silicones may be linear or cross-linked. If a straight chain means linear, if a cross-section and network means as cross-linked silicones. Why these silicones are cross-linked or linear means they have a due to very high thermal stability. Thermal stability, you know the syntax tank, everything is made up of silicones. They are called as high temperature polymer. You can withdraw any high temperature, withstand with any high temperature. Now type of silicones, linear silicones. First we'll see the linear silicones. They are obtained by hydrolysis and subsequent condensation of dialkyl silicon chloride. Dialkyl means R2SiCl2. Silicon tetrachloride means SiCl4. Instead of substitute, remove the 2 chlorine and substitute to alkyl group R2SiCl2. Aryl means, what is aryl? Ar2SiCl2. Aromatic compound is aryl, Ar2SiCl2. Now we see the types. Silicon rubbers. They are bridged together by methylene or similar group. Instead of this R2SiCl2. For this R you can substitute methyl group Me or CH3. So you must write Me twice SiCl2. Okay, or similar groups. Silicon resin. They are obtained by blending of silicones with organic resin such as acrylic esters. Cyclic silicone means these are obtained by hydrolysis of R2SiCl2. Okay, dialkyl silicone chloride. So tomorrow we'll see the preparation and what are the types of silicones, how to draw also. Okay, tomorrow we'll see that what are the types of silicones again, and the preparation of silicones and uses of silicones. Thank you, students.